Welcome back to The Explainer. So, today we're tackling something that is literally one of the most frustrating roadblocks in AI development right now. I mean, have you ever built a really fantastic AI agent, spent all this time giving it hyper precise instructions, only to realize it completely forgets who you are the literal second you start a new chat? It's basically 50 First Dates, but for software engineering. Well, today we're fixing that. We are diving into a really fascinating technical implementation from MarkTech Post that solves this LLM amnesia once and for all by building an agent-native memory infrastructure using a tool called Memori.
Okay, let's just quickly pull up our roadmap for today. First, we'll look at the core LLM memory problem. Then we enter Memori and look at the basic setup. From there, we'll dive into multi-user data isolation, agent personas and sessions, and some advanced agent workflows. And finally, we'll wrap up with why this all actually matters.
All right, section one, the LLM memory problem. So why exactly do your AI agents forget? This is a universal pain point that pretty much every single AI developer hits the moment they try to move from a fun little demo to a real production-ready app. It's so frustrating, right? You spend 10 minutes explaining your exact preferences, your project constraints, all your goals to a chatbot, and then bam, you refresh, start a new session, and it's a totally blank slate. The reason is that by default, large language models are completely stateless. They literally have zero built-in mechanism to retain context between sessions. Every single prompt you send is treated as if it's the very first time the AI has ever spoken to you.
And that brings us to a really crucial comparison. Looking at this, on the left, you've got your standard LLMs. Because they treat each conversation in complete isolation, you are forced to constantly re-inject your context back into every prompt. You know what that means? It eats up your token limits, it drives up costs, and honestly, it just wastes your time. But on the right, we have persistent LLMs. Now, these are the holy grail. We're talking about applications that actually retain useful context across interactions, learn about you over time, and just pick up exactly where you left off. To make that jump from the left to the right, we really need a robust memory infrastructure.
Moving on to section two, enter Memori and the basic setup.
The source material walks us through a Google Colab workflow to get this running, and honestly, it is surprisingly straightforward. Step one is just installing Memori right alongside the standard OpenAI package. Easy enough. Now, step two is a really vital little detail if you're using Colab. You have to configure Nest Async I/O. This is absolutely essential because it preps the notebook to handle asynchronous execution, completely saving you from those annoying runtime issues and nested event loop errors. Finally, step three is creating and registering both your synchronous and asynchronous OpenAI clients.
So, the crucial point here is that after you register those clients, you're officially establishing what's called an agent-native memory infrastructure. Think of it as this completely invisible layer that automatically intercepts your OpenAI API calls and enriches them with your historical context entirely behind the scenes. You don't have to manually pull from a vector database anymore, no more pasting huge chunks of data into your prompt. Memory just does all the heavy lifting for you, essentially making the model inherently stateful.
All right, let's get into section three, multi-user data isolation. Now, remembering things is great and all, but crossing the streams and leaking one user's data to another, yeah, that is a massive security and privacy failure in any production environment. Luckily, Memori handles this beautifully through multi-tenant isolation. And this brilliantly illustrates the concept. Imagine Alice shares some personal facts with your app. Memori securely scopes that data exclusively to Alice's identity. If Bob logs in a minute later and starts chatting, he gets his own completely separate memory bank. The tutorial actually tests this exact scenario, storing details for Alice, switching over to Bob to store totally different details, and then returning to Alice. And the system flawlessly retrieves Alice's personal facts without mixing in a single detail from Bob's profile. Zero leakage.
Okay, section four, agent personas and sessions.
Let's move on and see how this builds, because you might be wondering, what happens when a single user has multiple, completely separate workflows going on at the exact same time? Well, it turns out the secret weapon here is something called the process ID. By assigning a specific process ID, you can actually create distinct agent personas for the exact same user. It intelligently routes memory to specific roles. So if you have a project-specific session, let's say Alice is building a fast API app, the process ID groups all of those highly technical project decisions together, totally isolating them from, say, her everyday personal chat history.
To make this totally clear, just look at Alice's setup here. She has a fitness coach persona with its own process ID, and that specific agent only recalls her fitness goals. Meanwhile, her meal planner persona, running on a totally different ID, exclusively knows what she wants for dinner. Her workout agent isn't suddenly going to start suggesting heavy lasagna recipes, and her meal planner is definitely not going to ask about her deadlift max. The context is perfectly scoped, completely organized, and highly reusable depending entirely on the task at hand.
Which brings us to Section 5, Advanced Agent Workflows.
Look, simple text retrieval is one thing, but we all know modern applications demand way more complex functionality. The implementation we're looking at doesn't just stop at basic synchronous queries. Memory actually handles the tough stuff beautifully. It supports incremental memory with streaming responses, which means that even when output tokens are arriving incrementally, like that cool typewriter effect you see in ChatGPT, the memory layer still intercepts and processes everything seamlessly. It also fully supports background processing via asynchronous OpenAI calls, which is an absolute must-have if you're building high-performance apps. And it smoothly handles highly realistic multi-turn support scenarios.
Let's ground this technical stuff in a real-world customer support use case that was tested in the tutorial. Meet Charlie. He's interacting with an AI customer support agent. During his first session, he gives them his email and the specific support plan he's currently subscribed to. Now, with a standard LLM, if Charlie's internet drops or he just opens a new chat window the next day, he literally has to type all of that stuff out again. But here, Memory retains Charlie's support plan and his email context across completely separate, totally brand new conversations. The friction is just entirely removed.
And finally, Section 6, Why This Matters. We've dug into the code concepts, the collab setup, the data isolation testing, but let's just zoom out to the big picture for a second. Now, what's really interesting about this slide is the ultimate goal here, to build AI agents that do not treat each conversation in isolation, but instead retain useful context across interactions. By adding this invisible memory infrastructure layer, developers cannot easily build things like highly personalized assistants, reliable customer support bots, and really complex multi-agent systems where context is preserved seamlessly. You're basically moving away from simple amnesiac chatbots and stepping into the world of true digital companions and functional workflows.
So I'm going to leave you with this final, kind of thought-provoking question. If your AI could remember everything, properly scoped and securely isolated, of course, what would you build next? The whole limitation of LLM amnesia is officially becoming a thing of the past. It's time to start building smarter, much more persistent applications. Thanks so much for joining me on this explainer, and I will catch you in the next one.